Hmm. Good afternoon, everyone. So, how are you today? Kamusta naman kayo? Are we all here?
Hello, sir. Good afternoon.
The Marlon, Trisha, Michelle, Mary Grace, Jojo, Alex, Marlon, and Marlon din. Marlon. So, ilan
Dalawa.
kami kalagawan? 4, 5, 6, 7, 7. Okay, 7 attendees for this afternoon session. All right. So, we will be talking about a very special topic today, which is machine learning, part of data science. But before we talk about machine learning, so we have 4 types of analytics in the data science space. And what we tackled last 4 meetings is the descriptive analysis or descriptive analytics. When we usually focus on descriptive analytics, we are like data analysts. So we work as data analysts when we are delving into descriptive analytics, which is the part of data science. So what does it mean when we say descriptive analytics? Descriptive analytics is the process of examining the past data to understand what has happened in the past. It involves summarizing historical data and identifying patterns, relationship in the data. So descriptive analytics is used to answer questions, what happened and how many. Of course, in descriptive analytics, you can also do some like diagnostics. There are things that you can implement to perform diagnostic, which it is called drill down analytics, where you really dig deeper and understand why is it happening. So usually diagnostic analytics is the process of examining the past data to understand something that happened or why that thing happened. It involves analyzing data to identify the root cause of the problem or issue. So diagnostic analytics is used to answer questions like why did it happen and what caused the problem. Let's say a scenario is you wanted to know the performance of senior employees in a BPO versus junior employees. Usually, you can see that on your descriptive analytics, you can see that many tenured employees tend to have low calls or low performances. Okay, on your graph, maybe when you do your visualization. But maybe uh, the reason that it happened is that when you are a senior employee in a BPO, you usually handle cases that are hard to solve. So now you are asking or you are answering the question, why did that happen? Why did in the graph showed many senior employees have fewer calls than higher employees? So probably the cause of that problems is that junior employees tend to answer more calls because those calls are considered easy to solve. So that is diagnostic analytics. You are analyzing what is the reason why it happened. So it needs to have a drill down approach to understand the visualization. And now when it comes to predictive analytics, we are going to use some mathematics, statistical methods in order to perform predictive analytics on our data set. So what is predictive analytics? Predictive analytics is a process of using historical data to make predictions about future events. So this is more focused on predicting future events. It involves building models that can be used to predict future outcomes based on past data. Predictive analytics is used to answer questions like what is likely to happen and what will happen if we take an action, or possibly what can be the price of the house, what can be uh, the score of this student when the student takes the board exam. So we can predict what will happen if we have past data. Let's say I have a story. The story is you have a student where all of his grades in mathematics are high, like around 90, 94, 97, 98, 99, 100. So most likely, we want to predict the score of that student if the student tries to take uh, the board exam when it comes to mathematics. So let me just pull up a Microsoft Excel to illustrate a sample. Okay. So let's say this is the student, and for us to know what will be the prediction of the scores, we have different kinds of students, like student 1, student 2, student 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 5. Now, their math entrance score and their math subject grade. So let's say we normalize the scores to be from 0 to 100. So we have 88, we have 90, we have 76, we have 80, we have 81, around 85, and then we have 67, and we have 90, and then 70, 82. Okay. So with this one, we can actually predict what will be the, let's say, if we have a student which is number 6, and we only get his entrance score, like his entrance score is 85, we can actually predict the possible math subject grade of the student, even if there is no, the student doesn't have math subject grades yet. We can actually predict from the past data. So this is the past data from student 1 to student 5. So based on this past data, we can use that to predict the grade of student 6. Okay? So, and the last one in terms of of analytics, we have prescriptive analytics. Prescriptive analytics is the process of using data and analysis to recommend action that can be taken to achieve a specific outcome. It involves identifying the best course of action based on the data and the desired outcome. Prescriptive analytics is used to answer questions like what should we do and what actions will lead to the best outcome. Usually, the prescriptive analytics is like providing three options to your client. So let's have another story. So the story is, let's say you have three clients, and then your three clients, you have one client and you want to prescribe based on the liking of your client. So first you ask questions to your client, and you want to know if your client is, let's say, wanting to have the third approach or the second approach. Let's say your client is wanting to buy a car. So you present them three prescriptions uh, of a car. So the first prescription of the car is based on the answer of your client. Your client is an employee or a teacher. So he said his annual income is 30,000 per month. So option one or prescription one, you are prescribing a motorcycle to your client. And then since your client does not want to ride a motorcycle because sometimes it's dangerous in the road to have a motorcycle. So based on that criteria, you are suggesting another option. So the other option is to have a hatchback, because hatchback cars are usually economical and it's not expensive. Then your your client has a potential to actually buy a car that is around 2 million, even if your client is a teacher and has a salary of 30,000 a month, but he has a savings of 2 million, so he has a potential to buy actually an expensive car. So you're taking a chance if your client, a teacher, would want to buy a car based on features, not in the economical side of your choices. So you have three choices because you are anticipating the randomness of your client. So your first prescription is one, he can buy a motorcycle. Number two, he can buy a hatchback car because that is not a motorcycle. It has four wheels, but it's not as expensive as buying your third choice, which is a luxury car. However, that luxury car will have a high appraisal value if the customer wants to sell it off after few years of using it. Still has a value. Like for example, Mustang car. So eventually, that is prescriptive analytics. You will present three solutions or three courses of actions to your coming from your analytics. So it is a combination of descriptive analytics and a combination of predictive analytics. So whenever you are doing prescriptive analytics, you are a very advanced data science practitioner because you can both perform data analysis and uh, prediction on the data. Because doing both of it, you will try to compose an action plan for your client. So that's the reason why understanding the concept of data science is the hottest or sexiest job in the industry right now because of the facets of the things that you can do in the industry. So you can be a simple data analyst using descriptive analytics. You can be a level 2 data analyst because you already know how to do diagnostic analytics. You can be a data science uh, professional because you know descriptive analytics, diagnostic analytics, and predictive analytics. And then you will become a senior data scientist if you know all of this or you know how to apply it in a business setting. Descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. So if you try to look at yourself, where are you right now here on this for uh, four things in our data science class for analytics perspective? Maybe you are already here. Once you finish the course, probably you can do descriptive analytics already, right? Teka lang, answer ko lang itong inquiry mo, student. Okay. So having said that, we will be focusing on predictive analytics. In predictive analytics, we will go with machine learning. So we will be implementing machine learning algorithms. So the topics inside machine learning algorithms are, so in predictive analytics, we can have machine learning. And in machine learning, we have supervised learning and unsupervised learning. Uh, Supervised reinforcement learning, and what else? Semi-supervised learning. So these are the four types of machine learning. So we will be focusing on the first type of machine learning, which is supervised learning. And we will choose regression. So usually in regression, we will do prediction. Okay. So we will do prediction in regression. So let's first understand what is the linear regression. Linear regression, if you remember your statistics, this is used to there are different kinds of way to use linear regression. We can also use that to predict something or to test an hypothesis. So right now we're going to use linear regression to predict, all right? So let's have this example in Excel. So what we are going to do here is we're going to predict this value, okay? So let's try to graph our chart. So we need to select um, math, entrance score, and math subject grade. So I will use insert and do a scatter chart. So basically this is what is happening on our data. Okay. So we can actually have a trend line. So this is the trend line. All right. So we can also format it. What we can do this in this one is to, where is the show gradient formula? Trend line. Okay, so the trend line, we can also display the R square value. Also R squared, and we can display the equation. So this is the equation. So this is the equation to predict uh, the possible grade of the student. However, our R squared is 0.04. Therefore, our prediction might not be accurate. Okay? So because this is affected by the R squared. So to predict this value, the formula is y multiplied by 0.1129. Okay, so the x is 85. So 0.1129 times 85 plus 76.77. Okay, so that's the formula. Now let us just compute for that. Let's compute for that. Copy equals enter. So the answer is 86.36. So that is the prediction of the possible math subject grade of student 6. So 86 will be the predictive grade. All right. So we're using the linear regression formula here. So that's our prediction. However, we don't know yet the mean squared error. So let's say if I'm going to use the actual value, let's say 88. So we'll use 88 instead of 85. 88. So it's 86.70. But the actual grade is 90. So having said that, the error is 90 minus 86. We have an error of 3.2 as our error. 3.2% as our error. So therefore, this is 86.70 with 3%, 3% lang. 30% error or 3% error. So meron siyang error na ganun, no? So it's not not close enough. Meron siyang ano. Pero actually, we need to compute for all of the data sets. So this is just an error for one, but we need to get the mean absolute error. MSE. So mean squared error. So this is the mean absolute error. We need to get the mean squared error. Or sorry, this is an absolute error pala. But we need to get the mean squared error. So meaning we need to get all of the errors for our test case and get the average. But we're not going to do that anymore kasi that's going to be tedious. But you get the point. There is such a point there merong error, no? Meron tayong error kasi dito sabi ano lang siya 0.4 yung correlation niya. Pero tingin ko kaya yan 0.4 kasi konti lang yung dataset natin. So let's perform a bigger dataset na lang, no? Let's say I'm going to close this one. I will not save it. So I'm going to open a much bigger data set. So ang i-open natin is yung cities.csv. I-open natin. I-apply din natin yung gawa natin. Let's say dito, ang kukunin ko is latitude and temperature. So I'm going to copy them and place them into a new sheet. Okay, so now I will use them for scatter plot. Okay, insert scatter plot like this. So this is the scatter plot. Okay. So let's try to understand our scatter plot first. My question is, do you remember your do you have a subject linear regression on your college STEM nung nag-science kayo dati? Meron ba kayong linear regression? Press 1 kung meron. Naalala niyo ba to? Yun. Okay. So, isa lang. Okay. Before we go on with this one, let's try to have a simple game. I don't know if nagawa ko na sa inyo to, pero let's have a simple game first so that you will have an idea of linear regression. Okay. So this is called guess the correlation. So let's have a new game. Okay, let's have a new game. Okay, so the mechanics of the game is you're going to guess the correlation. So the correlation means 99, meaning 1 or 99%. So you can put 99% there, or you can estimate it to 0, 1. So from 0, 1 to 99%, you will try to guess based on the graph that you are looking at. So based on this graph, what can be the guess correlation? So you have 0 to 1 and 0 to 1 in both of the X and Y axis. Anybody can answer by typing. So you want me to have a demo? Okay, sige. Ang demo, let's say, ang hula ko dito, my guess for this correlation is around 30. 30. Okay? So if my answer is correct, I will have gold. If my answer is wrong, I will lose life. Okay? So I will press enter. Okay. So I am wrong. So the true R is 0.66. My guess is 0.30. And the absolute error is 0.36. Okay. Right now, the mean error is 0.36 because that's the first one. So we have another one. Next. So I think this is 0. I think this is 0.9 because uh, scattered siya, no? May tawag dyan eh, heterostasicity ba yan? So it's scattered, all right? So malino naman ako. My answer is 0.9 but actually the answer is 34. All right? So ito I think 09. Dito na ako mag-ano, 09. Yan. So the answer is 15. My answer is 09. So hindi siya more than 10% yung error ko. Kaya ako nagkaroon ng gold. Okay, may one life pa tayo. So I think this is 89. Okay, 89. Enter. Okay. It's actually 92 but my score is but my guess was 89. Therefore, I only have 0.3 error. That's why I gain a heart and plus gold. So my mean squared error is 1.8. Pag pinagsama-sama yung mga mali ko kanina, ang aking mean error is 0.18. So ito, I guess, mataas din to, mga around 90. Tama. Okay? Ito, mga around 30 siguro. Okay, sabi niya 4, pero 30. So ito mga I think 50. Mataas siya 84, pero 50 lang ako. Alright? So this is, I think this is 09 again. So I failed. Okay. But did you get the point? Do you get the logic in this one?
Yes, sir. We get the idea. Thank you.
Okay, so it's your turn. Your turn. What is the correlation of this one? Point 90. Let's try. Point 90. Correct. Almost 6%, 0.6%. Correct. So we did not lose any hearts there. We gained 1 gold bar. How about this one? Uh, let's try the answer of Jojo. So, Jojo, you will be responsible if we don't, or if we lose a heart right now, after this. Okay. Yes. Oh, correct. Nice one. So because of that, we gained 5. So the answer of Bonnie, 0.45, we might lose a heart if we will try to guess with 45. Uh, Alex is 65. Also Alex, we will lose a heart. 70, Michelle, I think we will retain a heart. Okay, so another one. How about this? This is a very challenging correlation. Scatter flat. Any other? 2, 4. I will choose Marlon's answer, 45. Are you ready, Marlon? We are going to blame you for this if you are wrong. Okay, let's try Marlon's answer. Oh, it's actually 0.6. So we have 39% difference. So the answer of Alex might be close to it, and also answer of Trisha. Pero parang hindi din pala. 2, baka hindi. Last one. Okay. Last one, guys. I will not blame anyone else anymore. Okay, for this one, I will use the answer of Alex. 0.45. Oh no, it's 74. Okay. So the answer of Michelle might be closer enough because it's 74. Okay, thank you for participating our simple game. I hope you've learned something from that. Now let's try to understand different types of correlations. So let me just show it to you using our internet. Negative correlation. So usually a negative correlation is, okay, this is better. So let's try to understand different kinds of correlation. So this one is a sample of a negative correlation because the trend line, or if you will try to observe the scatter plot, all of the circles or dot points are like from from up going to down. So why does this happen? Let's say we have the y-axis hot chocolate sales, and then we have ice cream sales. Okay. So meaning if we are going to have higher hot chocolate sales, the weather might be cold. If the weather is cold, people try to tend buying hot chocolate instead of an ice cream. So when the hot chocolate sales are up, obviously the ice cream sales are down. So if we try to correlate two of them, they are negatively correlated. So how can we provide an insight out of that? We can just say that in our sales, sometimes there are correlating types of products, or we can basically say that they are like associated, but in a negative way. So how they become associated? They become associated by means of when this product, hot chocolate sales, tries to have higher sales, opposite is happening on the ice cream sales. But we are actually not saying that they are directly correlated. Or should I say, the cost of high sales of hot chocolate sales is actually the the dropping of the ice cream sales. So we're not saying that that's the cause, because there is what we call the concept of causation and correlation. Uh, it happens sometimes that there is a correlation of something, but it does not mean that that is the cause or the direct cause of what is happening to the other. Okay, let's say this is the scenario. You are having a data. You try to to have a data set of your, let's say, the slimming pills versus your weight. The more you intake of the slimming pills, the the less weight you have. So sometimes it's not the slimming pills the direct cause of you losing weight. Sometimes it's a different uh, cause. So that's why when we do it with science, we are saying maybe this is just a placebo effect. They are not really the cause. So as a scientist, you are trying to prove what is the cause of something by means of trying to scientifically guess the reason why. So in this example, hot chocolate sales and ice cream sales, though hot chocolate sales is not the reason why ice cream sales are dropping, but they are correlated because we might say that people are buying more hot chocolate because of the cold weather, and people, because of the cold weather, are less buying the ice cream products. Okay, so that's negative correlation. There is also a positive correlation. So the positive correlation looks like all of the data points are from low going to upward, and the trend line is from left upward going to the right. So what is the example of a positive correlation? Do we have an answer here? Okay. So if we have a positive correlation, let's say the number of correct answers on a test and the percentage of correct answers on a test. So if we are having more, one, so if we have a positive correlation with this example, number of correct answers on a test and a percentage of correct answers on a test, meaning the students, if they have more answers on the test paper, the possibility that they have good grades or percentage of correct answers will become higher, the chances. Okay. So that is a positive. Also, one of the examples of a negative correlation, or sorry, the positive correlation is whenever whenever the what else? Positive correlation. What else? Can you give a positive correlation based on what you've understand? Can you just guess an example of a positive correlation?
Pwede ba sir yung ano, hot weather, like sunny day, tapos yung um, volume of person, volume of people going into swimming, parang ganun.
The volume of person going to
People
where?
sir, going to like outing or swimming, ganun.
I see. Yeah, possibly, yes. If the weather, this is actually a good example of correlation. There is a correlation of people going out for a vacation, especially going to the beach when it's sunny, because people wanted to relieve themselves from the dryness of the weather because it's very humid, right? Okay, education and income. When you have more education, you will get more income. that's what I've that's what I've understood, no? Kay Michelle, if I'm going to plot that on the scatter plot. Positive correlations. We're talking about positive correlations right now. So hours spent on study and student grade. Okay. So there is a possible correlation of hours spent on study and student grades. But my question to Andrew Is this also an example of causation? Causation, meaning this is the absolute cause of what you get. This is the absolute cause of the result from you getting a good grade. Yeah. So that's a like a palaisipan, right? If it is causation or correlation. Positive correlation from Alex, higher cholesterol, higher chances of diseases. Yeah, that's a good example of correlation. So what is the reason behind correlation? So we're trying to correlate something even if they don't really have the direct cause. Usually in science, we do that because we wanted to know what if they are correlated, right? That's the, and having said that, I'm going to show you this example, spurious correlations. Okay. Uh, okay. So these are what we call spurious correlation. Hindi ko na siya ma-view. Bakit? Can't be reached. Ayun, pwede pa rin. Ayan, this is an example of spurious correlation. What can you say about this one? So the meaning of spurious correlation is it refers to a statistical relationship between two variables that is not meaningful or does not have a causal basis despite appearing to be correlated. These correlations occur due to chance or the presence of confounding variables rather than any true underlying relationship. Spurious correlation can mislead and lead to incorrect interpretations or conclusions. It is essential to exercise caution and consider additional factors when interpreting correlations to avoid falling into spurious relationship. So in science and scientific predictions, there is a thing that is existing called spurious correlation. So ito, tignan natin. US spending on science, space, and technology correlates with suicides by hanging, strangulation, and suffocation. They are very highly correlated. Look at the graph, right? Okay, another one. Number of people who drowned by falling into a pool. Films Nicolas Cage appeared in. Meaning, because of the films Nicolas Cage appeared in, people are trying to fall into the pool more often. Parang sabihin na lang natin, si Nicolas Cage ba may ano noon, may problema doon? So meaning in correlation, we really need to test to be safe in doing a correlation. Sometimes uh, we do more scientific computations, but obviously so that we don't go into spurious correlations, we try to know if the phenomenon has a certain degree of causation. Okay, so let's say, for example, emotion and facial recognition, probably they have somewhat a degree of causation, because as humans, when we see the face of a person, we tend to know what is that person's emotion, feelings of the moment, as of the moment. So probably there is a correlation of facial expression to the person's emotion at the moment. So in order for us not to be with this kind of scenario, spurious correlation, we should sense that our data should have a certain degree of causation. Parang katulad ng somewhere like the hot chocolate and the ice cream sales. Okay, so having said that, if if a certain data set
May question
has
pala ako, sir.
okay, ano po 'yan?
Causation, sir, same thing lang ba siya, sir, with the coincidentals, mga gano'n? Pag nagko-coincide sila,
Hindi, pwede pa rin nating sabihin na spurious 'yon.
spurious pa rin.
Sa scientific ang computation ang ginagamit talaga diyan is the p-value. Parang
Hmm.
yung kailangan mong gumamit ng distribution sa statistics, gagamit ka ng distribution analysis
Yung mga
of
Z-score,
the
sir, parang gano'n.
standard deviation. Uh, Kailangan hindi siya more than 3 standard deviations from your population, or else that's an outlier. Kasi spurious correlation can be considered total outliers even though they are correlated. Pero they exist. There is spurious correlations. Meron ganun. Yun na nga yung in-example natin. Nangyayari talaga siya. Kasi by chance. Talaga by chance. So again, you can use your hunch. Kaya meron tayong tinatawag na empirical methods. When we say in science, when we say empirical methods, we can use our observation. 'Di ba nung naalala ninyo yung science ninyo nung nandun kayo sa chemistry, ginagamit niyo yung observation first to perform ang hypothesis based on observation. So then after that, you perform some kind of like hypothesis testing. So yung hypothesis testing, yun yung makukuha mo yung p-value. Pero we're not going to tackle that here because that is statistics. And we're talking about predictive analytics. So they are like hindi siya, parang katulad nung sinabi mo kanina, coincidental, pero they are like overlapping with each other, but they are not the direct cause of it. So here, if we try to observe the phenomenon, so parang dito nagkakaroon tayo ng tinatawag nating related literature and studies. So ano ang related literature and studies natin? Sabi ng mga tao, hearsay, kapag mataas ang lugar, gaano kataas ang temperature? Mataas o mababa? High or low temperature? If the position of the area is of high latitude, what is the value of the temperature, high or low? That's our related literature and studies. So let me ask you questions. In Baguio, is it high temperature there or low temperature there? Of course, there's low temperature. So let's say another mountain. Can you name another mountain, or is it safe to say that if you are on top of the mountain, the temperature might seem low in top of the mountain? Di ba tama? Siguro, probably, hindi siya sobrang lamig, pero there is a point na malamig siya kaysa dun sa kapatagan or city. So that's our related literature and studies. So what we want to prove here is that we want to predict the correlation of first we wanted to prove the correlation of temperature and latitude. So this one, we have the data of latitude and temperature. We want to plot it on a scatter plot. So this is our scatter plot. And let's say we want to guess the R square of this one. So in Excel, we can actually check the trend line. So for the trend line, let's change the trend line into color red. All right. So this is the trend line. Let us also make it the width of, ayan. So yan yung trend line natin. So meron tayong tinatawag na error dyan. May mga error yan. So ang error niyan is the distance of the points to the trend line. So the trend line is uh, our regressor. So we can actually, by clicking on a trend line, we can also view the R square. So this sample has a correlation of 67. Okay. And the equation is this one. So in order for us to predict using Excel, no, pwede tayo mag-predict actually. Ayan, laki. So big. Okay. So this is the formula in order for us to predict. So we need to get the input, which is latitude, the so our independent variable is the latitude. And our dependent variable is temperature. Therefore, in order to predict the dependent variable of a given input, let's say we get 39. So we get 39 as our input. So 0.436. Okay. Then 30.2 only. Take note that 0.436 is How can I put sign on it? Negative. Oh, all right. So this is our input. We multiply it by that. So we get first 0.9, then we 0.4, 36 times 39 as our input, x plus 30. So we need to put also parentheses so that we will perform multiplication before addition. So our predictive temperature for 39 is 13. But here, do we have 39? 36.99. 36.99. So 14. But 36.99 is actually 18. So we still get what is the inverse of 67? So we still get 33% error. So we still have 33% error for this one. Therefore, instead of getting an accuracy of 18.67 for our prediction, we only get 14.08. So we still have 30% error from the data set. So in order for us to improve our predictive model, we can basically increase our data set, because in a linear regression, the more data set you have, the chances we get heteroscedasticity result from our scatter plot, and we will improve our R squared, right? So this is a negative correlation because whenever we have a high latitude, our temperature goes down. And whenever we have low latitude, our temperature goes high. So this is true for almost all of the scenarios in, let's say, in our environment. So our predictive model has an error of 30%. Like, if I'm going to relate this to a person, are you going to hire a person if his ability or his scorecard is always 70%? I would ask you a question. Would you hire that, or would you have that person? So same goes to our model. So the reason why we do uh, because there are a lot of machine learning models out there. So we select the best model for our data set, because some models do not fit to the requirements of the data set. So some experiments of machine learning is finding the right model. However, if you're okay with 70% accuracy, because for the reason that this is the only machine learning model, for the meantime, for me, 70% score is good enough. At least it's not 50-50. If it is 50-50 or 50%, it means it has a low correlation, or there is a chance that is just a chance. There is a chance that is totally random. Okay? So if you reach 50-50, that's totally random. If you get 70%, at least we are getting into something. So having said that, let's try to program this one in Python. But before we program this in Python, let's have a 15-minute break. Okay, is that okay with everyone? Okay, so okay, let's continue our discussion. Okay, so let's go here with our code. I'm going to share this to you. Share. Okay, press one if you all have the for the data. For the data, I'm going to upload it here. So this is the data, the fish data. So here on our sample notebook, we will be using linear regression. So we will be using the library of pandas, numpy, if ever, seaborn, sklearn, model selection, the train test split. We also be using sklearn linear model and linear regression. Sklearn metrics such as accuracy score and mean square error, and also matplotlib for plotting. So your data set should be saved here on our session storage, just like what you are seeing on mine. Here you can see I use the cities and the fish CSV. So right now we're going to use fish.csv, or we can use also a different file. So probably what I want to use here is the cities muna. Okay, so I'll be using the CS. First, I need to run this code so that I will reload all of the libraries. Then next is I'm going to run the cities.csv so that I can use cities. So another code. Okay, so our cities has city, country, latitude, longitude, temperature. Okay. And also we will going to use only the columns of, we need to use the x independent variable will be temperature, and the y dependent then variable is temperature. Sorry, the independent variable. Independent variable, sorry, will be latitude pala. And then the dependent variable is temperature. So therefore, our cities will have only cities. So we will have only latitude and temperature. So it will only have latitude and temperature. Okay. Next is what we can do here is cities dot core. So it's -82. Our correlation is -82. Heat map yata gamit nila. Heat map. SNS heat map. So you will use here the heat map. So we get the correlation. Okay. So we will plot the correlation matrix for the cities. Ay, ba't ganun? Pag dalawa lang, di pwede. Oh, sorry. Yan, okay. May mali pala doon. So this is the code for the, I'm going to paste it on our chat box. Ayan. So pag latitude sa latitude, syempre 100%. So that is 1. Pagka temperature naman, it's negative 82. Kasi di ba negative correlation sila? Because pabagsak yan eh, pabagsak. So, meaning, pagka kinorelate natin siya dito, for example, cities dot plot dot scatter. So, X and Y latitude. Mali spelling, latitude. Ayan siya, di ba? Okay. So that's why it's negative 82 because it is negatively correlated. Okay? Next is we are going to do this one. I'm just going to copy this one and then paste. Sure. So for this one, we already have X and Y. Or do we have X and Y? So instead na data, gagamitin natin dito is cities and then cities. So dito ilalagay natin yung mga gagamitin natin na features. So far, ang gagamitin natin dito is our independent variable, which is latitude. And then our target or our dependent variable is temperature. So we will perform a split test with 0.2 test size. So anong ibig sabihin ng test size 0.2? Meaning if we have 1,000 instances or data, we will get the 20% for the testing size. And then the random seed is 42. Okay. So ibig sabihin up to 42 yung layo dun sa pagkuha niya ng random sample para sa test size. So meaning our training test will have 80% of the data and then Y test and Y train will get the 20% of our data. Imagine if your data set is 1,000, you will get 20% number of data to the test and then 80% to the train. Okay. So what happens? We're going to use the model linear regression. So we're going to put that on a regressor variable. And now we will train the model. So basically this is training the model because of the function fit. We are fitting the model. So here we get the the X train and the Y train. Okay, so the X train and the Y train. So meaning na mapupunta dito yung 80% na latitude tapos dito mapupunta yung 80% na temperature. Okay, so if i-fit nila yon, magre-regression line. Then we will try to predict using the test set. Yung 20% mo naman, ipipredict natin. Okay? Using this latitude. So using the latitude from our total data set na napili, ipipredict natin ang kanyang Y prediction. So let's play. Oops, nag-error. Ang error niya. Mix continuous and multi-class targets. Hindi ba pwede yun? Wait lang ah. Ayun. So, okay. So, nagra naman na siya, no? Linear regression, Y-pred. So, we get the mean square error and the R2 score. So, ang R2 score niya is 59. Yung Excel natin kanina, di ba, ang sagot niya is 60, 60 or 70, ganon. Tapos, ang mean square root niya dito is 30%. Tama, 3% pa rin talaga. So, therefore, meron tayong error na makukuha. So, pag nag-predict tayo, may error tayo na 30%. Okay. Now, next is, let us use the model to predict. Okay. So, gawa ko ng code dito. So, di ba meron siyang model? Ano yung model niya? Regressor, di ba? So, we can use regressor here. Regressor. Regressor dot predict. Yan. So, gamitin natin dito yung input. Yung ginamit natin dati. Input. Please enter or input the latitude to predict the temperature. So in order for us to predict input, so we will use the regressor. So, okay, so let's try to know the prediction. So kanina sa Excel natin, 36.99 pala, no? So gamitin din natin dito. 36.99. Ay, sorry, gawin natin siyang float pala. Float. Ulitin natin. 36.99 got ano to the array got scalar. Oh, wait lang ha. So you need to change this one. So we need to use np.array. So we need to use np.array, then convert the latitude float. Then we need to reshape. So this means that we need to use an array for our input for the prediction because this one is an array. Diba? So check natin. X test is what? It's a data frame. And pag niran natin to, 36.99. It's 14. So, yung latitude input, kinonvert lang natin siya into an array. Okay, so x test latitude. So pwede siyang input. Basta same siya, kaya kailangan natin siyang i-reshape to an array. So ang answer niya dito is 14.21. Kung titignan natin dito sa Excel natin, hindi nalalayo yung sagot. Tama. Oh no. Maglalag yung computer ko. Ba't kaya? Hindi na kaya. Okay, ang sagot natin dito, yung 36.99 is 14.08. Ang prediction naman niya dito is 14.21. So, there's no significant difference, right? So, meaning, we can also predict in Excel using this formula, or we can use Python. So, ito yung prediction niya, no? 14.21. Isa pa, tignan natin kung ano yung estimate niya. 36.99. Estimates kasi ito eh. O 14, ganun pa rin, 14.21. Okay, so yan, nakakapag-predict na siya. So kung marami tayong ipipredict, marami lang tayong i-input. No? Ayan. Probably we can use this for this one. Actual temperature and so actual temperature predicted. Tama ba predicted temperature? Ayan. So ito yung kanyang regression of the actual predicted. So bakit siya 59 lang yung R squared? Kasi kung mapapansin nyo to, may mga errors dito sa bandang gilid. Ayan yung mga outliers. Tapos ito yung malalayo. Ayan. May mga outliers tayo na pwede nating tanggalin para gumanda yung ano natin, model natin. Okay? So that is how you use linear regression for for ano, for one feature. So paano kapag maraming features? So nandito na tayo sa fish. So lagay tayo dito, fish. Paano pag fish naman yung example natin? Fish.csv. Okay. Ibaba ko lang yung code nung sa fish. So ito, so this is the fish market dataset. Ito, ang gagamitin natin dito is yung fish.csv naman. So sa fish.csv, meron tayong species, weight, length 1, length 2, length 3, tsaka height. So ano bang itsura niyang fish market natin? So what is the, let me change this one. Instead of data, yes, use fish. Tapos, fish. Don't worry, share ko to sa inyo at the end of our lesson. So, better makinig lang muna kayo. No? Okay, so we have species, weight, length. We need to know the actual values. So for species, we have brim. Okay, so there is some kind of categorical value when it comes to species. Okay, so for the weight, we have numerical value. Okay, so we also have length, length 2, length 3, height and width. So how many species do we have here? So let's try to understand some values. Let's say for the fish, we wanted to get species and then unique.
And unique yata
Ano,
siya, sir.
ano yan?
And unique.
Anong meron?
Sa unahan, sir, ng U, merong N. And unique siya dapat, parang ganon.
And unique. Okay,
Mhm.
we just Hmm. Seven species. So we have 7 species. And then what we wanted to look at this one. Look, this one is What else do we have to look at this one? I'm just going to try if this is possible. I see. For this one, if we will try to use shorter versions. Okay. Ayan, yan yung gusto kong makita. So, this is the types of the fishes. And then we have and unique, I see. So the number of unique column values in the species. Number. Yeah. So types of fishes or species. Yeah. So meron pala tayo ditong bream, roach, whitefish, parky, perch, pike, smelt. Ano kaya yung mga itsura nun? Perk. Ano ba yung perk? Perk type of fish. Ito yung perk. Perk type of fish. Parky. Wala. Okay, so this is one parky. Para siyang ano, no? Bisugo na hindi ko maintindihan. Ito, this one. Parang hindi naman yata parky yan eh. Anyway, so fishes yan siya, no? So, usually we do have like this kind of data set. So ito, yung ginawa natin dito sa baba is we use label encoder para instead na yung mga bream, parky, roach, whitefish, perch, ang mangyayari, matatransform siya into numbers 0 to 6 probably. So yung bream yung 0, yung roach yung 1, yung whitefish yung 2, parky. So, and what I did here is instead of overriding the species, I created a new column. So, ganito yung pagkikreate ng new column. Ano ang kanyang laman? yung 02. Ayan. So gamitin natin dito instead na data, fish. Tapos fish. Ayan. Tapos run natin. Okay. So later, for our regression kasi, we cannot use this species. The reason why we change this one into numerical values. In regression problems, we will predict using continuous numbers or possibly numbers. So we try to scatter plot the width and the height. Okay. Or we can also use species encoded. Let's check. Okay. So this is what happens if your data is not continuous. With it will look like that. So dapat continuous siya, no? So kapag nauulit-ulit, katulad nito, nauulit-ulit siya. Ayan. So we should have a good estimator. Okay. Let me look for good estimators. Okay. Anyway, that would, di siguro mag-workout yun, yung naisip ko. So, if we will try to push it through, I am thinking that we will not have a good outcome with this one. But still, this is possible. Kasi numerical pa rin naman yung transform natin dito sa gilid. Although, hindi lang ako confident, I'm not confident if the answer for this one will be a good prediction. So let's try to do a correlation matrix. So in this correlation matrix, you will try to notice what are the best features that are correlated. So length 1 is a good correlation with length 2. Sorry, length 3 rather, because it's 99. So length 1 to length 3 to length 1. It's a good correlation. So we can use length 3 as an independent variable to length 1. How about height? Height has 72% correlation to weight. So we can predict the weight if we have height, but it's just 72. How about height and length, 63? So the best one to use here for height is weight. We can possibly look for 72% correlation for the weight. However, there are others that are good predictors. For weight, where's weight? For weight, we can predict weight using length 1, using length 2, and using length 3. And then also height. Uh, for height, for height, 72. So for height, we have 72. So meaning, we can predict the weight using length 1, length 2, length 3, and height. Because it's still significant to use height even if it's just 72. Okay. But if we will try to include, the species encoded, tama ba? Species encoded, tama. Species encoded. Species encoded is a bad. It's a bad correlation. So we will not use species encoded because it's bad. Look at this one, -7. We can correlate species to height, but it's a negative correlation. So we intend not to use it because it's negatively correlated. But let's try with our experiment. So if we try to predict height, species encoded has a negative correlation, but it's good. However, it's negatively correlated. Okay. If you want to look at the point, mm, we can use height and species encoded. So let's try to look at it. Yan. So negative siya pag ganun. If you try to imagine the trend line, it's going down. Whenever our species encoded is up, our height goes down. Okay. So meaning the species of the fishes are from small to big in terms of height. From small to big in terms of height. Okay. So that's how you analyze the correlation matrix. So we pick length 1, length 2, length 3, and height. So we will not gamble with species encoded. So this is our training and testing. Now we will select weight, length 1, length 2, length 3, height, and width. So according to this one, it's better to use weight. So I'm going to use weight and I'm going to remove it on the x independent variable. So by just using length 1, length 2, length 3, and height. Tama, no? So, kasi dito, length 1, okay, length 1 for weight. Yan. Yung height pwede, yung length 3, yung length 2, at saka length 1 pwede. Siyempre, hindi natin siya pwedeng ilagay yung weight sa training natin because we will get 100% bias. Okay? So that is our multiple features will be saved to the X and Y. Now we use X and Y for our train test split. So it will be 20% for the test and 80% for the training. Then it's 42% random state. Again, we will use regression and then predict. Okay. So let's try. Multiplus. Probably there is a problem with this one. Instead, we will use this one. Kunin lang natin to. Tapos, lagyan natin siya dito. Okay. So, R squared is 88. And our mean squared error is this one. Predictive weight. Let's check on the graph. Okay. Mukha naman siyang okay pero kasi kulang yata yung data. So I guess medyo kulang lang yung data. Ano ba yung sagot natin dito? We have 59. Dito nga 59 eh. Pero kasi yung ano sa kanya mataas, yung mean square error. Yung mean square error kasi nakukompute siya dito sa layo ng ibang points dun sa regression line. So umabot siya ng 16,000. Siguro mali lang yung computation nito pero it's 88. Okay, so let's test it, no? Test natin yung model natin. So basically, I'm just going to get the codes from earlier. Ito. Ay, di pala. This one. Let's test our model. Please enter input the weight of the fish. Ay, no pala. To test that, kuha tayo ng input galing dito. So, kukuha tayo nitong length 1, length 2, length 3, at saka height. Tsaka width. Ay, kulang pala ng width, no? Kulang ba ng width? Sama natin yung width. Ulitin natin. Sama natin yung width. $88 pa din. So, ang ipapasok natin sa kanya is ano yung length? Kuha tayo dito ng example. Ito, 23.9 for the length 1. 23.9, comma 26.5. Okay. 31.1, comma 12.38. Gawin natin 12.38. And yung width is 4.7. Okay, so save that into input. And then run. Sorry. Input na ganun. Ay, sorry. Ginagamit ko pala yung latitude input. Kaya pala fish input. Weight. For weight input.
Hello, sir. Hello, sir.
Meron akong sinasolve.
Hello, sir.
Ano akong sinasolve?
Um, sir, suggestion, sir.
What
Hello.
if
Sir Marlon here, sir. Narinig, sir, ako.
ganito siya? Tapos tapos instead of this, we use testing ed data from input. Let's try to test. Uh, mm, 1, 2, 3, 4, 5, 6. Ito. Okay. Okay, so gusto niya kasi 5. 5 din yung inputs, 5 din yung use cases. So basically, what happens here is that uh, X testing that shape. Gusto niya kasi 5 by 5 ang kanyang gamitin dito sa predict. So ibig sabihin, nagkaroon lang ako ng 5 examples. So 5 ang nilagay ko dito. Alright. Pero ang prediction niya is 31. Ang prediction niya is malaki. Sa una, 13, 15, 18, 430. Medyo tumama. Tapos, negative 156. For this one. Kaya naging ganon kasi mali pala siya. Dapat pala ito puro to. Ayusin natin, no? For length, dapat 23, 5. 5 yung kailangan natin, ano? For length 1, so gawa lang tayo ng random, 26.5, 23.9. Hindi, gawin na lang natin pare-parehas. So, dapat pala nandito yon 26.5. Tapos nandito yung 31.1. Tapos nandito yung 12.38. Tapos nandito yung 4.7. So, ganun lang. Copy-copy lang natin. $23.9, 31.1, 12.38, 4.7. Tapos, i-match natin dito. So, 31.1, okay, tama. Ay, hindi. 23 pa rin. 23.9, 26.5, 31.1, 23.9. Hanggang 3 na lang siguro. Tapos, i-0-0 na lang natin yung iba. 4.7. Okay, run natin. 23%. Nagkaroon siya ng isang error. So far, consistent naman siya sa dalawa. Okay. So, 23.9. 26.5. Tingnan lang natin. Curious lang ako kung 31.1. 23.9. 47. Curious lang ako kung magkakamali siya ulit or consistent siya. Ayun, nagkakamali siya consistently. Ay, hindi. Kasi mali yung values. 12. 12. Ayan. 12.38 pala. Ayan. Check natin. Consistent naman pala siya eh. Okay. So, anong ibig sabihin nito? Meron tayong, ito yung kinuha nating data, yung BRIM, 340, ay sorry, 23.9, 26.5, 31.1, 12.37, tsaka 4.7, 12.3, tsaka 4.7. No? So, meaning, ang kanyang weight is 340. Ang prediction niya, 360. Consistently. So, meaning, meron talaga siyang error na lumampas. Lumampas siya ng konti. So, kung 340 yung actual, 21 yung nilampas niya na weight. So, meron siyang ganong klase ng discrepancy sa prediction. However, nakapag-predict naman din siya. So, kung kukopyahin din natin to, again, 23.9, consistent naman siya doon. 0.9, 26.5. Ginawa lang natin to kasi para lang mag-match dun sa input values sa X niya. Okay. Yan, para pantay lang sa paningin natin. Okay. Kasi ang gusto niya 5x5 eh, no? 5x5. Nag-error siya kanina because 5x1 lang yung in-input natin. Ibig sabihin, meron tayong 5 features or X pero isang row lang. So gusto niya 5 rows with 5 features. Gusto niya, pag pinipredict niya, 5x5. So ang in-input natin sa kanya, 5x5. So this is 5x5 na transform natin sa ano Siguro lagay na lang natin dito validation instead of X testing. Validation. So in our validation, the actual value is 340, but the prediction is 361. Okay. So if we plot it, this is how it looks like. Okay. Yeah. So actually, I have another data set. Kunin natin yung Boston house pricing data set. I'm going to share to you the file, by the way, on our chat box. So this is now the updated version. Okay, so I'm going to share the file. For your reviewer. Then no, I'm not talking. So I'm getting a data set here on my end, and I will upload it. So please, you can actually do the regression in this one. So we'll be renaming this one, two. Okay. So the file is, I'm going to upload another data set. So this is one is called real estate. Oh, naglalag na siya. Election. Di na yata kaya ng memory ko ah. Okay, so we will be using the real estate data set. Over here at the bottom. So we will do predictions of how much will be the price of a certain real estate. So it ends here. And natin ang text. And so first and foremost, we wanted to get the data, real estate data. PD dot so I'm going to upload the fish data set tuloy the real estate data set. Okay, so this is the data. We need to understand our data first before we do anything. So what are the columns? So the columns are number, X1 transaction date, X2 house age, X3 disuse MRT station, number of convenience, latitude, longitude, house price, unit area. So it has actual house price. Ayan. So ito magandang example to kasi pwede natin gamitin as y-axis yung house price of unit area. Okay, so we still have 1 hour. I would like you to perform prediction of the house prices using the real estate CSV. So initially, dapat alam niyo yung columns and then basically you will remove number kasi hindi naman siya kailangan dyan. So for instance, yung real estate data natin is composed only of real estate data. Composed only of this values. So wala yung number. Okay. So this is basically removing number. Yan. Okay. So what you want to do is also to perform the correlation matrix. So you have an idea. And perform different kinds of scatter plot from, let's say, this one. Uh, that plot that scatter for the x-axis, we will get house age. And for the y, we get the okay. What an interesting scatter plot, right? This one is also an interesting scatter plot. So if you're done, I want you to analyze what is the best feature to know the actual unit price of the real estate. What is the best feature to get the nearest nearest house price prediction?
So, ayun po, yung mean squared error niya, 63, tapos yung R squared niya, 0.61. Actually, tinry ko din yung mga iba. Napansin ko dito po, um, pagka sinama si X2, mas lower yung error. Pero mas mataas yung R squared or yun, kaya hindi ko sure kung tama ba yung pinili ko dahil convinced ako based dito sa correlation or kung dito ba dapat nag-base ang score na ako. Anyway, dito ako nag-stick sa yung mga correlation. So, yung chart ko, ganito yung itsura niya. Ayun po.
Okay. So let me just give some supplementary explanation on what you've done. So I like the way you tried it with different independent variables such as x4, x3, x2. Okay. So actually, what is the best approach from your approach? I think the best approach is still basing on the heat map. So in the heat map, you really need to select your candidates which are having high values of correlation. So you selected x3, x4, x5, x6.
Opo.
Okay. I was wondering here dito sa ano. There is a multicollinearity with x6 and MRT station. So probably in that sense, this affects the totality of the performance of your correlation. Actually, that is also true with the others. Kasi pag ginawa nila to, it will also have the same outcome. So in this example pala, meron siyang multicollinearity, meaning correlated si x6 longitude kay x3.
Ito.
Dito sa x6 longitude tsaka x3, negative 81. May meron siyang multicollinearity. Ayan, negative 81. Yan. Si x3 distance to the nearest MRT station at saka kay x6 longitude. Pag sa baba, ayan. Sa baba. So kapag ganyan, tatanggalin yan si x3 tsaka si x6 longitude. Yung negative 81 na yan, tatanggalin yan. To have a difference.
Dito po mismo.
Probably that could have an impact on the. You can actually fix that later. It's okay. So in this example, correct, you are using the heat map just like what I have done earlier. Sa heat map makikita yung mga matataas yung correlation. Ibig sabihin, yun yung mga i-retain mo. And then for this one, yung x6, negative 81, yung correlation niya, tatanggalin yung 86. Pwedeng ang mangyari dyan, hindi kahit kung ipapattern natin siya sa house price, 0.52 pa rin siya. Tapos yung x3 distance to the nearest MRT station, 67 siya. So if I'm going to be asked here, tatanggalin ko na lang si x6 longitude kasi 52 siya. Mas mataas yung 67. Or pwede nating i-experiment, what if tinanggal natin si x6 longitude, niretain natin si MRT, ano kaya yung effect? Tapos, kung tinanggal natin si MRT at niretain naman natin si X6 longitude, ano kaya yung outcome? So doon papasok yung parang science niya, yung nag-e-experiment tayo kung ano yung best feature. I think kasi pag tinanggal natin yung dalawa, it will have a significant decrease in the outcome. So in data science, when you omit or remove data from your data sets, if your data sets will be few, that will impact the accuracy of your model. The the more features you have, the better, but there is always an optimal feature. In this case, ilan lang yung feature natin dito? 7 yata. Pag nagbawas ka pa, mas papangit pa siya. Possibly pumangit pa siya. So yun lang naman yung comment ko dito sa result ni Alex. Okay. Good kasi may output kagad. How about Marlon? Do you have something to share?
Yes, meron sir. Siguro iaano ko na lang start video. Teka lang. Almost
Yes.
similar lang din kay kay tawag dito kay Alex, pero paano ba to? Ay, switch.
Yung iba, just to add more pala, habang nagfi-fix si Marlon, yung iba ang ginagawa, hindi lang nagbe-base sa correlation, gumagamit pa sila ng tinatawag na Pearson correlation or the alpha. So dito, hindi ko muna siya pinakita yung alpha kasi baka yung iba sa inyo, nagsisimula pa lang dito sa correlation or sa linear regression. Pero isang technique din yon, you will know the alpha or the p-value, yung p-value technique. Okay, sige, go ahead, Marlon.
Okay sir, tinry ko rin sir yung same approach yung ginawa ni Alex on different independent variables. Kaya lang ang closest kasi na nakikita ko medyo correlated sa house price is yung X4, number of convenience stores. So based on this heat map, ayan. So 0.45 yung nakita ko closest to 0.5, diba? Siya yung parang largest. So hindi ko na sir pinansin yung mga negative. So yan na lang sir yung ginamit ko. So I decided na kunin yung X4, X5, tsaka X6 as X values and Y naman yung house price nung yung pinipredict natin. So looking at the accuracy, looking at the result, MSE is 68.28 and then R squared is 0.59 and then predicted price is 50. So given this particular input, for example.
Okay, correct.
Okay, and then plotting sir yung kanyang actual versus predicted. So this is the graph that shows that.
So inevitable pa rin talaga yung error natin, no? With this one. So meaning if this is actually happening in the real world, that's why we don't stick to one model, and what we do is we do ensemble of models or probably select the best model for our prediction. So with this one, this is all good for me. Everything is both of your presentation is correct. I just appreciated kasi in-implement ni Marlon yung prediction ng new price. Ayun. So yun yung importante kasi sa industry kapag ginawa natin to, kailangan may paggagamitan tayo. Imagine what your model afterwards this can be used by, kasi sa industry mayroon tayong mga tinatawag na IT, may mga tinatawag tayo na developers. Yung model natin, pwede natin yan i-extract and then gamitin nila for a certain purpose. Siguro predicting the house prices. Actually, ang best nga nito ng regression is meron pa nga isang dataset yung yung automobile prices naman. Ito yung house prices. Kaya siya konti, kaya hindi pa natin na-reach yung pinaka the best feature dito. Kasi maaring sa data gathering natin, hindi natin nakuha yung tamang features. So, if I am a if I am a data scientist, ang suggestion ko dito para mag-improve to is to add more features. So, hindi sapat yung mga features na meron tayo dito sa dataset natin. Kasi we can only reach to a point na 50% lang siya. So, in short, lacking pa yung yung features ng real estate. Siguro pwede nilang ilagay dito, may opinion is pwede nilang ilagay dito bathroom count. Siguro ganon, bathroom count. Kasi nakalagay lang dito, pagka qualitative natin to, number of convenience stores, medyo hindi. Pwede pa nga dito kung may hospital to eh. So probably, if magde-data gathering tayo sa susunod, ang isa-suggest ko dito para talagang tumaas yung prediction ng model natin. I-include ko yung hospital, yung SM, school, kung may malapit na school, and so on. So, ang recommendation ko dito, kulang ang features natin. So, X1, X2, X3, X4, X5, X6 is still lacking. So, these features are not enough. So, we need to add more features. So, pag nangyari sa real world na ganito yung scenario, ang best solution is to add more features. Okay? Kasi kung 7 lang yung features natin, wala na tayong magagawa dyan, yan na yan. Wala na tayong magagawa. So, ang kailangan na lang natin gawin is to dagdagan pa siya ng features. Then again, do another heat map correlation, something like this, and select the optimal features. So, yun yung gagawin natin.
Question, sir.
Sige.
Nakakalculate ba, sir, yung nako-complete yung accuracy for this, or hindi siya applicable sa regression?
Hindi, iba yung ng regression, MSE lang.
MSE lang talaga yung measure.
Kasi ang regression, ang output niya is continuous values. Range. Hindi siya katulad ng classification na type 1, type 2, type 3.
Okay,
Class
sir,
1,
thank you.
class 2, class 3. Which is dun tayo papunta sa susunod. Ang regression na ginagamit para sa classification, na kamag-anak ng linear regression is logistic regression. So possibly yun yung topic natin for next meeting para sa classification naman tayo. So ngayon, ito ay isang supervised learning algorithm. Paano natin siya nasabing hindi siya supervised learning algorithm siya kasi pinakita natin dito yung price. Binigay natin yung mga price. Ito. So meron siyang facts, yung house prices. Yung y dependent variable is the fact. Therefore, it's under supervised learning. Ngayon, kung hindi tayo magre-regression, anong mga model ang gagamitin natin for regression? For non-regression? Yung mga logistic regression, decision tree, k-nearest neighbor. I don't know if narinig niyo yan. Kung data science fan kayo, narinig niyo na yun siguro sa mga YouTube, ganyan-ganyan. So, ang first step kasi ng machine learning talaga is linear regression. Kaya dito tayo nagsimula. And this is also the foundation of higher level algorithms such as CNN. Okay, gumagamit din ng regressor yung CNN for the loss function. So nandito yung fundamentals ng mga neural networks. Parang sabihin natin ito yung stretching part ng machine learning. Kunyari nag-aaral tayo paano mag-basketball, nandito pa lang tayo sa stretching part. Hindi pa talaga actual yung paano magpasa, paano mag-dribble. Siguro probably hindi naman stretching. Siguro yung linear regression. It's more of like yung jumping jacks, ganon. Jumping jacks. Parang ganun pa lang yung napag-aaralan natin. Pag pinag-aaralan natin yung linear regression. Parang jumping jacks pa lang siya ng machine learning. Wala pa talaga sa actual sports. Parang warm-up pa lang siya. Pero lahat naman na natutunan natin dito is going to be beneficial to the advanced parts. So kaya importante siya, no? Okay, so do you have any more questions? It's already 6:09 on our time check. If there is no questions, see you on the next session or kailan ba yun? July 15. Okay. Saan yung chat ko? Walang chat. Okay, thank you very much for attending this session. I hope you learned something. May natutunan ba kayo or wala na? Nahirapan ba kayo?
Marami,
Or
sir. Ako na-appreciate ko.
na-appreciate niyo naman, yes. Mas
Thank you.
ma-appreciate niyo to kapag dumating na tayo sa mga bandang session, ano na ba to? 5? Session 6, 7? 7. Session 7. Kasi ang goal ko is at least sana may parang output kayo. Parang output. Pero gagawin ko kayong groupings for that final project para hindi maano yung iba, maiwanan. Yung iba na catching up pa lang, ganyan. Okay. So I will be sharing this on our Leon's account. Tingnan nyo na lang doon for your copy. Okay, thank you very much. Bye. See you next meeting.
Thank you, sir, and everyone.
Thank you.
Have a good day. Bye-bye.